Hey guys, so here's part 2 of the lesson 4 notes. So now what we're going to do is use this idea of the standard normal distribution and apply it to some of our problems. So let's go to the next example. So, oops, let me keep going. And there we go. Okay, so for 6 and 7, we're going to continue using the mean of 220 seconds and a standard deviation of 26 seconds. So it says Ed Sheeran and Beyonce made the list with the song Perfect Duet, which is 260 seconds. What percent of songs are longer than the perfect duet? Okay, so we want longer than. So what we're going to do is use our standard normal distribution to basically find the percent. Now you may be wondering, well, now we've learned these two, right? The standard distribution, the standard normal distribution, and the normal distribution. How do we know which one to use? Well, it will always say, okay, use the normal distribution to find the percent, blah, 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 okay? That's when you use the bell curve and you use your 68, 95, 99%. If it doesn't say that, or if it says use the standard normal distribution, then that's what you're going to be using. Okay, let's go ahead and do this. So in order to use the standard normal, remember we got to find the z-score. So that's the first step. So we're going to take the value, subtract it from the mean, and divide it by the standard deviation, which was 26. We plug that into our calculator and we get 1.54. Remember, guys, we always, for our z-score, we always round to 2 decimal places. So make sure you do that. Always round to 2 decimal places. Okay? So now what we're going to do is we got to think about this 1.54 and look at our standard normal table. So this is where you want it. Now notice our z-score is positive. So we want to go to the positive side. And here we're going to look at 1.54, or sorry, 1.5. Now remember, our hundredths place is the 0.04. So we want to find the intersection between 1.5 and the 0.04. Remember, this 1.5 and 0.04 is the same thing as 1.54, right? If we added these together, that's what they give you, okay? So when we look at that, we get this value of 0.9382. Now, here's where we got to be careful, right? So this gave us the decimal of 9.382. We got to think about this, our longer than. So when we think about this idea of being our longer than, is that going to be on the right hand or left hand side of, let's say, our z-score here, right? So our z-score is at 1.54. So will that mean we want things on the left or right? Well, we want things longer. That means that's going to have to be the right side. So because we want the area to the right, remember that means we are going to have to do 1 minus our area here. So we're going to have to do 1 minus the 0.9382. And so when we do that, we get 0.0618. Don't forget, change this into a percentage by moving the decimal over twice. So we get 6.18%. So you are going to have to use those keywords to know, do you want the right or the left area? Okay, let's get example 7. So it says Taylor Swift has songs on this list with widely varying song lengths. We Are Never Getting Back Together is only 193, while In Game is 245. What percent of the songs are between these two song lengths? Ooh, so here, because it's asking us in between, right? So we got about 193 here and 245 here. I'm just estimating. This is what we're wanting, okay? So what we're going to have to do is actually find the z-scores for both of these. So we're going to have to do that first. So for the 193, we do 193 minus 220 divided by 26. Remember our mean and standard deviation, they gave it to us at the top. So we plug this into our calculator and we get negative 1.04. For the z-score of 245, we have 245 minus 220 divided by 26. And then once again, you plug that into your calculator, we get 0.96. Now, we are going to find the areas for both of these. So we have negative 1.04. So we want to go to the negative side of our chart here. So we're going to go to the negative 1.0. And then as stated, we have this 0.04. We want this. So we want to find the intersection between these two. Remember, this really means negative 1.0 plus your 0.04. That's what it represents. So when we see that, we see this value of, it looks like 0.1492. So we're going to just write that down. Okay, and then we want 0.96. So let's find the area for 0.96. We got to go to our positives. So for the 0.096, I have to go to 0.9, and then I want to go to my 0.06, and that gives me the 0.8315. So that's the area for that part. Now, what are we going to have to actually do with these two? Well, notice that, remember, these two values represent, right, the area to the left, okay? So basically what we're going to do is, because both of these represent the area to the left, we're actually going to have to subtract these two areas to get this middle part, okay? So anytime they ask you for between, you're going to have to subtract the two areas. Now, if we think about this, right, we're thinking about percentage. Percentage cannot be negative. So when we subtract, we're going to take the bigger of the two areas. So that is the 0.835, and then subtract it from the smaller to have a positive percentage. Okay. So when we do this, we're going to get 0.6823. And then don't forget, we got to change this to a percentage. So we get 68.23%. Okay. So just to recap, if you need to find values between, you subtract the two areas. If you are trying to find the area to the right, you do 1 minus the area of the left, and then you get your percentage there. Okay, let's try one more example. So let's look at example 8. So it says, when professional golfer Jordan Spieth hits his driver, the distance the ball travels can be modeled by a normal distribution with mean of 304 yards and standard deviation of 8 yards. On a specific hole, Jordan would need to hit the ball at least 290 yards to have a clear second shot that avoids a large group of trees. So what percent of Spieth's drives travel at least 290 yards? Okay, I would like you guys to go and try this on your own. So go ahead and pause the video and try this on your own. Okay, let's see what you guys got. So what I did first was determine, because it does say on the normal distribution, I actually did the normal distribution. So I had 304 as my mean, and then I used my standard deviation. Now I noticed 290 is smaller, so I just did the left-hand side. So when I kept subtracting, so I did 304 minus 8, that gave me 296. And then 296 minus 8 gave me 288. So I noticed that 290 is not one of my standard deviations on the normal distribution. Because it is not, I'm actually going to have to use the standard normal distribution to find my answer. Okay, so remember how we do that is we do the z-score. So I did 290 minus 304 divided by 8. It gave me a standard deviation of negative 1.75. Now notice, it says what percent of Spieth's drives travel at least. So at least means we want 290 or greater. So that means I want the area to the right of 290. Now remember, to find the area to the right, I'm going to have to do 1 minus the area on the left. So what I did was I took my z-score of negative 1.75 and I used the standard normal table. So let's go back to that. So we're at negative 1.75. So in order to find that, I need to go to negative 1.7 and then my 0.5. And where they intersect is this value. So this is the area to the left, 0.0401. So in order to find the area to the right, I have to do 1 minus that value. That gave me 0.9599, and don't forget to change it to a percentage, 95.99%. Okay, if you guys have any questions, just let me know. See you guys later.